Good evening, students. Hope you are very well. So today we will going to see some practice questions which have been covered in the JEE examination previously from the chapter solutions, and this is part 2. So let's start. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using the generative AI, which is experimental. So let's start with our first question, which is a MCQ question which covers the NCERT section 1.6 in the solution chapter. And the question says that for a dilute solution, Raoult's law states that. So if you consider a solution which is dilute, what will be the Raoult's law which states, or which from the given options, which is the correct statement, which is the statement or the definition for the Raoult's law? So the given 4 options are: the lowering of vapor pressure is equal to the mole fraction of solute. The relative lowering of vapor pressure is equal to the mole fraction of solute. The relative lowering of vapor pressure is proportional to the amount of solute in the solution, or the vapor pressure of the solution is equal to the mole fraction of the solvent. So you got some time, think about it, try to relate it, and then we will see the correct answer. Okay, so let's see. So for this given question, the correct answer is option B, which is the relative lowering of vapor pressure, which is equals to mole fraction of the solute. So the relative lowering of vapor pressure is basically the mole fraction of the solute, and if you solve it using the concept 7.8, the solution will say that the partial vapor pressure of each volatile component present in a solution will be directly proportional to the mole fraction or to its mole fraction in the solution. What does that mean? That the partial vapor pressure of each volatile component in a solution is directly proportional to its mole fraction present in the solution. Okay, and when you remove this proportionality sign, there will be an equal to and a constant comes. So the relative lowering of vapor pressure, if you write, it will be delta P divided by P naught equals to chi2, which is mole fraction of solute. Okay, this delta P is basically P naught minus P. That means the difference between the vapor pressure of pure solvent and the vapor pressure of the solution. Okay, divided by the vapor pressure of the pure solvent. This is the relative lowering of vapor pressure. This whole term is relative lowering of vapor pressure, which will be equal to the mole fraction of the solute. Okay, chi2 is mole fraction of the solute, and this equation is given as 1.25, is marked as 1.25 in the NCERT textbook. Okay, so the question asked was that the Raoult's law states what? Okay, states what? So the correct answer is option B, the correct statement, or you can say the correct definition for the Raoult's law, which says that relative lowering of the vapor pressure is equal to mole fraction of solute. Okay, now let's move on to the next question. This question is a MCQ question, and this covers the NCERT section 1.5 in the chapter solutions in the NCERT textbook. And the question says that an azeotropic solution of the two liquids has boiling point lower than either of them. When which condition will be applicable when the azeotrope azeotropic solutions of two liquid, they will be having boiling point which are lower than either of the one. Okay, either of the two liquids. So you have to tell that what will be the condition when this given statement will be applicable for the azeotropic solution. So the four given options are: shows negative deviation from Raoult's law, shows no deviation from Raoult's law, shows positive deviation from Raoult's law, or is saturated. So you have these four options. You have to identify which will be the correct relation, or what will be the correct statement, which is, justifying the given statement for the azeotropic solution. So you got some time, go through it, and then we will see the correct answer. Okay, so let's see. So for this given question, the correct answer is option C, that it shows positive deviation from the Raoult's law. Now, using the concept 7.16.1, the azeotropic solution or an azeotropic solution of two liquids has a boiling point lower than either of them when it will show a positive deviation from the Raoult's law. Okay, so this will be the correct condition which is satisfying the given statement. In case of positive deviation from the Raoult's law, the observed vapor pressure will be greater than the ideal vapor pressure, and boiling point of azeotrope becomes lower than either of the pure liquid. Okay, so according to the Raoult's law, we know that we have the Raoult's law gives the vapor pressure relationship between the solution and the solvent. Okay, that the vapor pressure of the solution is equals to the product of mole fraction of solvent and the vapor pressure of the solvent, right? Mole fraction is defined in the terms of number of moles. So the vapor pressure you determine by the Raoult's law, that will show, or this azeotropic solution vapor pressure will show positive deviation from Raoult's law. What does that mean? That the azeotropic solution will observe higher or greater vapor pressure than you derive from the Raoult's law. And what will happen, that the azeotrope solution will be having the greater vapor pressure, or you can say that they will show the lower than either of them. Okay, the azeotropic solution of two liquids will be the boiling point of the solution of two liquids of the azeotropic solution will be lower than either of them. Okay, so in the simple words, if we have an azeotrope solution, that means we have two solutions, first and the second, which we are mixing together. Okay, we are saying that when they mix and they become a mixture, this mixture has some vapor pressure. Okay, now the vapor pressure will be greater than the ideal vapor pressure which you derive from the Raoult's law, which is considered as positive deviation from the Raoult's law. Okay, now what it will cause? It will cause that boiling point will decrease, then the either one or the two solution. Let's suppose one has X boiling point, two has Y boiling point. So the boiling point of the mixture, of the mixture of one and two solution, will be, let's suppose, Z. So Z will be lower than X and also will be lower than Y. This we are saying. Okay, so this happens when the solution will show positive deviation from the Raoult's law. That means the vapor pressure observed will be the greater than the ideal vapor pressure from the Raoult's law, and this will decrease the boiling point of the solution, then they are pure in form. Okay, so the correct answer is option C, that it will show a positive deviation from the Raoult's law when the azeotrope solution of two liquids has boiling point lower than either of them. Okay, so C option is the correct answer. Moving on to the next one. Okay, this question is again a MCQ question and it covers the NCERT section 1.4 and 1.5. The question says that identify the mixture that shows positive deviations from Raoult's law. Okay, so from the given option, we have different mixtures given. You have to identify the one mixture which will show positive deviation from Raoult's law. The given options are CH3 whole twice CO plus CS2, CHCl3 plus C6H6, CH3 whole twice CO plus C6H5NH2, or CHCl3 plus CH3 whole twice CO. These are the four choices for the given mixture which is showing the positive deviation, and you have to identify which is the correct mixture. So you got some time, go through it, think about it, try to solve it, and then we will see the correct answer. Okay, now let's see. So for the given question, the correct answer is option A, which is CH3 whole twice CO plus CS2. Using the concept 7.13.1, the mixture CH3 whole twice CO plus CS2 will show positive deviation from the Raoult's law. Now it has some reason behind it. What will happen? The mixture that will show positive deviation from Raoult's law will be having weaker interactions between their different components than in their pure forms. Okay, what does that mean? That if you have a mixture, again we are supposing that we have two components, 1 and 2, you mix them and they become a mixture, let's say 12. Okay, now this mixture will be having the weaker interactions between the another molecule of this mixture. Okay, so the intermolecular interaction will be weaker than their pure forms. That means one, if you combine one with the one, if you attach one with the one or two with the two, this interactions will be greater than this interaction. Okay, so mixture that will be having weaker interactions between their different components, then in their pure forms, those will show positive deviations from the Raoult's law. Now, in case of acetone, which is CH3 whole twice CO, and carbon disulfide, which is CS2, the intermolecular forces between the acetone and the carbon disulfide are weaker than those which are present between acetone attractions and CS2 attractions. Now, this leads to a higher vapor pressure, which is considered as a positive deviation from the Raoult's law. Okay, so higher vapor pressure means the vapor pressure will increase due to this region, and higher vapor pressure from the ideal vapor pressure which you considered from the Raoult's law. So this will be due to the positive deviation of the mixture, and the correct mixture which will show the positive deviation is this acetone and carbon disulfide mixture. So the correct answer is option A. Okay. Okay, let's move on to the next one. Now this is again MCQ question, and this is this comes under the section 1.4 of NCERT textbook in the chapter solutions. The question says that a solution of two miscible liquids showing negative deviation from Raoult's law will have. So if you have a solution in which two miscible liquids are present, they will showing negative deviation from Raoult's law, and they will have what? You have to correctly match from the given four options. So the four options given are increased vapor pressure and increased boiling point, decreased vapor pressure and increased boiling point, increased vapor pressure and decreased boiling point, or decreased vapor pressure and decreased boiling point. So here in the question, we are talking about the negative deviation from the Raoult's law. This you have to consider while solving. So you got some time, go through it, think about it, and after that, we will see that what will be the correct option, correct answer. Okay, let's see. So for this given question, the correct answer is option B, which is decreased vapor pressure and increased boiling point. We use the concept 7.13.2 and in the question it is given that the two miscible liquids solution will show negative deviation. That means the AB interactions in the negative deviation solutions are stronger than the AA and BB interactions in the two liquids. Okay, if you have two components A and B present in the solution as a mixture, or you can say two miscible liquids in the solution, making a solution AB. Okay, so the interaction between the A and B, the interaction between the A and B are stronger than AA or BB. Okay, so that means the solution is showing negative deviation. And due to the greater interactions in the AB case, okay, the solution or the two solutions will be having the greater interaction among them. And due to that, A and B types of molecules have a lower tendency to escape from the solutions than the pure liquids. Okay, as they are holding together by the great interactions, the solution in which the two miscible liquids are present, that those two liquids are so much tendency or greater interactions among each other and they are holding together. So they will, in a very few amount, in a very lower amount, escape or convert into the vapor phase, or they will be having a very lower tendency to escape into the vapor phase from the solution. Okay, then the pure liquids, because pure liquids are having weaker interaction, they can easily convert to the vapor phase or go to the vapor phase comparatively than the AB interaction. Okay, so this results in the lower vapor pressure than the expected. And this, if the vapor pressure will be decreased, vapor pressure is the pressure of any gas, or you can say vapor pressure is the pressure which is created by the gas just above the surface of the liquid. Okay, and if the tendency of the molecules is decreasing to convert into the vapor phase, which is the cause of the vapor pressure, then the vapor pressure will decrease also, right? If there will be fewer molecules that will be escaping from the liquid's surface to convert to the vapor phase, the vapor pressure will also decrease. So this results in the lower vapor pressure than the expected as from the Raoult's law. So lower vapor pressure means the liquid will boil at higher temperature. That means the boiling point has increased. Boiling point has increased. The temperature which you need it to boil the liquid will be more and more. You have to provide more temperature to convert the molecules to the vapor phase and to help them escaping from the solution. Okay, so the correct answer is our option B, which says that the two miscible liquid solution, which is showing negative deviation from Raoult's law, will be having decreased vapor pressure and increased boiling point. Hence, the B option is the correct answer. Okay, moving on to the next one. This is an MCQ question, and this comes under the section 1.3 of NCERT textbook in the chapter Solutions. The question says that for a solution of gases A, B, C, and D in the water at 298 Kelvin temperature, the values of Henry's law constant, which is KH, are given as 30.40, 2.34, 1 0.56 times 10 to the power minus 5 and 0.513 kilobar respectively. Okay, so we have a solution of gases. The gases are A, B, C, and D at a particular temperature in the water, and the value of Henry's constant respectively for the respective gases are also given. In the given graph, the lines are marked as P and S corresponds respectively to. Okay, so we have given a graph here. The lines which are marked as P and S, that will correspond to which gas? This you have to tell. Okay, so this is a graph you can see between the partial pressure and the mole fraction of the water. And there are 4 different lines for P, Q, R, and S, and from which you have to identify that the line P and the line S will mark or will correspond to which of the gases. Options are A and C, B and A, D and A, or C and D. In this question, we have given the Henry's law as constant value. That means Henry's law will be applicable. Okay. So you have some time, think about it, try to solve it, and then we will see that which option is the correct answer for this question. Okay, let's see. Now for this question given, the correct answer is option A, which is A and C. That means the P and S line is corresponding to the line or to the gas A and C. Now let's see how. We use the concept 7.15 and solve this question. So according to the Henry's law, you know that pressure, partial pressure or vapor pressure of the solution is equals to KH times chi times mole fraction, and KH is representing the Henry's law's constant. A higher KH means the lower solubility of the gas in the water. The mole fraction is defined. You can also define the mole fraction in terms of solubility. So that means they are present in the product terms. That means one of them, if you find the value of one of them, the another will go in the denominator at another side. Okay, that means they are inversely related. So if one will be higher, another will be lesser. So higher KH means that there will be lower solubility of gases in the water. And the lower KH means higher solubility of gas in the water. They are vice versa. Okay. Remember that we have given the KH values for different gases A, B, C, and D. So the given KH values at 298 Kelvin temperature are for the A gas, the KH is 30.40 kilobar. For the B gas, the KH value is 2.34 kilobar. For the C gas, the KH value is 1.56 times 10 to the power minus 5 kilobar. And for the D gas, the KH value is 0.513 kilobar. Okay, now if you compare the highest value of the KH is in the case of gas A. That means the solubility will be lower, or you can say very lower, or you can say the most lower. Okay, so it will be the least soluble gas in the water, A gas. Okay, because its KH is the highest. Now the smallest KH is for the C gas. That means it will be mostly soluble because KH and solubility are inversely related. Since P has maximum partial pressure, now just you have to relate from this graph. We just only have to think about the P and the S line. Okay, the P line is this and the S line is this. P is decreasing, right? And S is here, which is at most a straight line. Okay, now the partial pressure value, if you see, the P has maximum partial pressure and S has minimum partial pressure, right? And you can also say that P has the maximum partial pressure That means it should have a maximum KH, right? Because partial pressure is given by KH times chi. So also in the kilobars here in the y-axis, we have given the partial pressure, and the KH value is also given as like this 3.40, 2.34, and all this. Okay, so highest KH is for the gas A, and you can see that highest vapor pressure, or sorry, partial pressure is for the P series or P line, right? And S line is having the lowest partial pressure value, which is for the C gas, because Henry's constant is equals to the partial pressure, right? You can consider this. If X remains constant, you can consider that P is directly related to the KH value. KH is higher, that means P is higher. So if P has maximum partial pressure, since P has maximum partial pressure, so it should have maximum KH, and S have minimum partial pressure, right? It is having minimum partial pressure. That means its KH should be minimum. So KH maximum is for the A gas and KH minimum is for the C gas. So P is responding or corresponding to the A gas, and S is corresponding to the C gas as per their KH values, which is given already in the question. So the correct answer is option A, which is A and C. A for the P line and C for the S line. Okay. Okay, let's move on to the next one. Okay, so this question is MCQ question, and this covers the NCERT section 1.2 in the NCERT textbook of solution chapter. And the question says that liquid M and liquid N form an ideal solution. The vapor pressure of pure liquids M and N are 450 and 700 mm of Hg respectively at same temperature. Then the correct statement is. So we have given some statements, or you can say some relation in our options. You have to choose the one statement or one option which is correct as per the given information. We have two liquids given, M and N. They are forming an ideal solution, and the vapor pressure of the pure liquids of M and N are given as 450 and 700 mm of Hg respectively at same temperature. So it is the extra information given as that the chi of M, the mole fraction of M is the mole fraction. Chi of M is representing the mole fraction of M in the solution, and chi of N is representing the mole fraction of N in the solution. Meanwhile, Ym is representing the mole fraction of M in vapor phase, and Yn is representing the mole fraction of N in vapor phase. Okay, so the four options given are chi M by chi N is greater than Ym by Yn. That means the ratio of mole fraction of M and N in the solution is greater than the ratio of mole fraction of M and N in vapor phase, or the ratio of mole fraction of M and N solution is equals to the ratio of mole fraction of M and N in the vapor phase, or the ratio of mole fraction of M and N in the solution is lesser than the ratio of M and N, the mole fraction of M and N in the vapor phase. Or the last option says that the difference between the mole fraction of M in solution and in vapor phase is less than the difference in the mole fraction of N and N in the vapor phase and the solution. Okay, so these are the four different relation given. As per the given statement or as per the given question, you have to identify that which is the correct option, which is the correct relation. Okay, so you got some time, go through it, and then we will see the correct answer. Okay, let's see. So for this given question, the correct answer is option A, that the ratio of mole fraction of M and N in the solution is greater than the ratio of mole fraction of M and N in the vapor phase. Using the concept 7.7 and 7.12.1, you solve this question. So liquid M and liquid N, they are forming an ideal solution as already given in the question, right? They are forming the ideal solution. So vapor pressures of the pure liquids M and N are 450 and 700 mm of Hg respectively, which is given. That means the ratio of mole fraction of M and N in the vapor phase is equals to, you can write it as chi M P naught M divided by chi N P naught M. Right? This you know that the vapor pressure is defined as the mole fraction and the vapor pressure of pure solvent product. Right? You can write it. So Ym is equals to chi M times P naught M, and Yn will be chi N times P naught M. So this is the equation marked as 1.22 in the NCERT textbook in the solution chapter. And from this, you can also write, you can just rearrange this equation and write it as chi M Yn. Okay, this will go here. So chi M Yn divided by the chi N Ym, this will go here, is equals to P naught N by P naught M. Okay, and when you put the values, it will be equals to 700 divided by 450 as per the given values. And 700 by 450, if you divide 700 by 450, as denominator is smaller than the numerator, this fraction will be greater than 1. Its value will be greater than 1, obviously. Right? What does that mean? That this fraction will be greater than 1. That means this fraction will be greater than 1. And if you rearrange this relation, that will also be the greater than 1 value. So chi M by chi N will be greater than Ym by Yn, right? X chi M by chi N will be greater than Ym. It will go here and will go again here, Ym by Yn. Okay, you just have to use the rearrangement, and you just have to rearrange this equation and put the values, and you have already determined that this fraction will be greater than 1. So this will be the correct relation which you determine, that chi M by chi N will be greater than Ym by Yn. And thus the correct relation is present in our option A, hence the correct answer is option A. Okay, moving on to the next one. This is also a MCQ question, which is from NCERT section 1.3 in the solutions chapter. Question says that for the solution of gases W, X, Y, and Z in water at 298 Kelvin, the Henry's law constant, which is KH, are 0.5, 2, 35, and 40 kilobar respectively. So we have given the Henry's law constant value for different gases W, X, Y, and Z. The correct plot for the given data is, now when you see this data, what will be the correct plot for this? We have given 4 options. The A option is this graph representing partial pressure and the mole fraction of the water, and they are Z, Y, X, and W graphs. The B graph is also between the partial pressure and mole fraction of water and the graphs of Z, Y, X, and W gases. Similarly, the C option and the D option graphs between partial pressure and mole fraction of water for the gases W, X, Y, and Z. You have to determine that according to the given data, which is the correct plot. You have some time, go through it, try to solve it, and then we will see what will be the correct answer. Okay, let's see. So for this given question, the correct answer is option A. Now using the concept 7.15, you can solve this question using the Henry's law. So the Henry's law constant is given already. So according to the Henry's law, the pressure, partial pressure will be equals to KH times chi. Okay, the Henry's law constant times mole fraction. This is the equations stated as 1.11 in our NCERT textbook in the solution chapter. And the pressure of gas will be equals to KH times, you can also write chi or mole fraction as 1 minus the mole fraction of the solvent, right? Because the sum of mole fraction of solute and solvent will be equals to 1. So for the mole fraction of solute, you can write it as 1 minus mole fraction of solvent, which is water. Now, when you multiply KH inside the bracket, it will be KH minus KH times chi of H2. Right? Let's suppose this is our first equation. Now, we compare the equation first with the straight line equation, which is y equals to mx plus c. Okay. So y is basically our representing our y-axis, x is representing our x-axis. So at the y, we have partial pressure. Okay, so y will be this. We have x as mole fraction, so chi of H2 will be x. Okay, so when you compare this equation with the straight line equation y equals to mx plus c, we get the graph which is given in our option A. Okay, so the slope will be negative because this is the slope. Minus kh is the slope, m. Okay, m here in this equation is minus kh. You can see the slope is negative. So when the slope will be negative and the partial pressure, or I can say the P of gas, is directly related to the kh. Its value is depending upon the kh value. That means the higher the value of kh, the higher will be the partial pressure of the gas. So we have already given the kh values. You can arrange the W, X, Y, and Z partial pressures on the y-axis as per the Henry's law constant. And you can then relate the first equation with the straight line equation, and then you can relate the slope, that the positive slope line is represented by this, right? Negative slope line is represented by this decreasing graph, and the zero slope is representing by the straight line in the graph. If this is y and x axis, right? If this is y direction, this is x direction. We have our respective graphs for different slope is like this. This is for positive slope, this is for negative slope, and this is for the zero slope. Okay, so as we have given the slope is negative, and we have also given the kh values. Okay, so we just put that the lowest kh value is for the W or gas. Okay, 0.5. That means approximate to 0. Okay, so if the kh value is 0.5, that means it is approximate to 0. So the graph of the W gas will be just at most related or at most equal to the straight line. Okay, which is already present in our option A graph. And also the highest kh value is for 40, that which is for Z gas, right? So 40 kh highest value, that means the minus 40 will be the slope, and then you can determine that which graph will represent the Z gas, and this all values are satisfying our option A, and that's why the correct answer will be the option A graph. Okay, let's move on to the next one. Now this again is a MCQ question from the NCERT section 1.6 and 1.4 in our solution chapter textbook. So the question says that the vapor pressures of pure liquids A and B are 400 and 600 mm of Hg respectively at 298 Kelvin. Now on mixing the two liquids, the sum of their initial volumes is equal to the volume of final mixture. The mole fraction of the liquid B is 0.5 in the mixture, and the vapor pressure of final solution and the mole fraction of components A and B in the vapor phase respectively are. So you have to identify three things: the vapor pressure of final solution, the mole fraction of components A and B in vapor phase as per the given information in the question. Okay, so the four options given for this question are 450 mm of Hg and 0.4 and 0.6, 500 mm of Hg and 0.5 and 0.5, 450 mm of Hg and 0.5 and 0.5, or 500 mm of Hg and 0.4 and 0.6. So you got some time, go through it, think about it, and then we will see that what will be the correct answer. Okay, let's see. So for the given question, the correct answer is option D, that 500 mm of Hg and 0.4 and 0.6. Now using the concept 7.11, we try to solve this question. So according to the Dalton's law of partial pressure, the P total of any solution will be the sum of the partial pressure of its all the components. That means if you are having a solution where the pure liquids are A and B, so the total pressure of the solution will be the vapor pressure of A plus vapor pressure of B. So you can also write the vapor pressure as P naught A, that means the pure vapor pressure of pure solvent. You can say vapor pressure of pure solvent times chi A plus P naught B times chi B. Okay, let's suppose this is first equation, and this equation is marked as 1.14 in our NCERT textbook in the chapter solution. So we have given that the P naught A, that means the vapor pressure of pure liquid A, is given as 400 mm of Hg. Okay, we have already given 400 and 600. So P naught B is 600 mm of Hg. Chi B is given as 0.5. The mole fraction of liquid B is given as 0.5 in the mixture. And we know that chi A and chi B, that means the sum of mole fractions of the components in a solution will be equal to 1. So if you know the chi B, you can determine the chi A from this equation. So chi A will be 0.5. 0.5 plus 0.5 gives 1. Now, when you substitute the given values in the equation first for the chi A and chi B, what we will get? That the P total is equals to 400, which is the P naught A, times 0.5, which is chi A, plus P naught B, 600, times 0.5, which is chi B. And when you solve it, the P total will be 500 mm of Hg. The mole fraction of A in the vapor phase, that will be Ya equals to minus of Pa by P total, right? And you can write it as P naught A chi A divided by P total, because Pa you can write it as P naught A times chi A. So you just have to put the values. So P naught A is 0.5, chi A is 400 divided by P total, which we just calculated, which is 500, right? So this will be equals to 0.4. And similarly, the moles the mole fraction of B in the vapor phase will be Ya plus Yb is equals to 1. You know that Ya plus Yb is equals to 1, right? The mole fraction of the components in a solution their sum will be 1. So if you know the Ya, you can determine the Yb. So Yb will be 1 minus 0.4, which is 0.6. Okay. So the vapor pressure of final solution is 500 mm of Hg. The mole fraction of component A is 0.4. The mole fraction of component B is 0.6. And this was the question asking. So the correct answer is option D, that is 500 mm of Hg, 0.4 and 0. Okay. So thank you very much for joining this session. This was all about the chemistry session for today. Thank you so much.